The photoelectric threshold frequency of a metal is nu. When light of frequency 4 nu incidenting on the metal, the maximum kinetic energy emitted of the photoelectron. We know the photoelectric equation is given by h nu equal to work function plus kinetic energy maximum. Incidenting photon energy frequency is 4 times. No change in the work function, but kinetic energy definitely increases. In this question, work function is given as h nu naught. Naught की जगह nu question में given है. So h for h nu kinetic energy maximum given as 4. This means 3 times h nu. So option 2 is correct. Hello, in this question, photoelectric experiment, the wavelength of the incident radiation is reduced from 6000 angstrom to 4000 angstrom, whereas intensity remains the same. Now we know the photoelectric equation is given as hc upon lambda work function plus EV naught, where this is called stopping voltage. Now we know the stopping voltage depends on frequency and wavelength, and it does not depend on intensity. So it depends on frequency and wavelength, but it does not depend on intensity. Means we are decreasing the wavelength, it is constant quantity, so we not must increase. By decreasing the wavelength, stopping voltage must increase because the energy increases. By decreasing the wavelength, energy increases. There is no change in the wavelength work function, so stopping voltage must increase. So option here 2 is correct. Photons absorbed in matter converted into heat is photoelectric effect. A source emitting n photons per second of frequency nu is used to convert 1 kg of ice at 0 degrees Celsius converted into water at 0 degrees Celsius. Suppose t is the time taken. In this question, h nu is the energy of one photon and n is the number of photons per second falling on the cathode, and here on water 1 kg ice at 0 degrees Celsius converting into water of 0 degrees Celsius. From ice to water, time taken here is T. The energy is equal to M into L. L is the latent heat of fusion. If frequency is constant, then h nu means energy of the photons is constant. But if n increases, then total energy increases, so current increases, so time will be less. So first option is correct. Now second, if n is constant and frequency increases, even then energy increases, so again time will decrease. If n and nu constant, means if n is less, nu is more. If nu is less, n is more, means current is constant, so time is also constant. It means third option is also correct. It means all the options are correct. So a correct option here is 4. Correct option is 4. Because all the 3 options are correct. Work function of a surface of a photosensitive material is this. In this question, work function is 6.2 electron volt. The wavelength you have to find if the stopping voltage is 5 volt. So here hc by lambda equal to work function plus ev naught. In electron volt 6.2 plus 5 So that is 11.2 and lambda will be Hc upon 11.2 is converted into joules. H is Planck constant 6.63 into 10 to power minus 34 into c speed of light on 7.2, 1.6 in 10 power 19. If we solve it, comes here roughly the region say less than 100 angstrom to 4000 angstrom. It means it is coming in ultraviolet. So ultraviolet region में ये आएगा wavelength. We solve it here, comes here 1773 angstrom. So it is ultraviolet region. Option 1 is correct. Hello. In this question, we have to find out the de-Broglie wavelength of electron with kinetic energy 120 electron volt. H mass and 1 electron conversion. De-Broglie wavelength formula here is H upon mv. It's P, so it can be written as H upon and root 2me. We put all the values 6.62 into 3 into 10 power minus 34 upon 2 into mass of electron 9 10 power minus 31 energy 120 इलेक्ट्रॉन वोल्ट को कन्वर्ट कर लिया जूल्स में. Solve it. We are getting 6.63 to 10 upon 38.788 angstrom. After solving it, comes here 1.1273 angstrom or approximately 1.13 angstrom. So option correct. Proton, a neutron, electron and alpha particles having the same energy. We have to find out the de-Broglie wavelength for each proton, neutron, alpha particle and electron. De-Broglie wavelength given as h upon mv or in terms of energy. Here h and e are constant energy, same for all the particles, and then wavelength is directly proportional to 1 by root of m. Here we know alpha particle is heaviest. Mass of alpha particle is maximum 4 times mass of proton, and mass of proton and mass of neutron is almost same. Mass of electron is very less. It means the wavelength for alpha particle mass is maximum, so wavelength is minimum. Lambda for proton and lambda for neutron, they are approximately same. Mass of electron is very less, so wavelength is maximum for electron. Here, option 2 is correct. So, in this question, Einstein photoelectric equation, graph between the kinetic energy and the frequency of incidenting radiations. Graph 4 is correct because we plot the graph between the kinetic energy or stopping voltage versus frequency. Graph starts from this place, means this is the frequency threshold. If the below the frequency than the threshold, then no electron ejected. If we increase the frequency more than the threshold frequency, then electron ejected with some kinetic energy, then we have to require here a negative voltage called stopping voltage. So graph 4 is correct. Answer 4. Fourth option is correct. In the photoelectric effect, the photoelectric current, the graph is here like this is the stopping voltage and graph is something like that, and this called the saturation current, positive voltage, anode voltage, and the stopping voltage. Here this is the photo current. So here saturation current depends on intensity. Current depends on intensity, correct? Potential difference, if we increase, current increases up to the saturation level, and current depends on the nature of the emitter material also, but saturation current does not depend on frequency. Kinetic energy depends on frequency, but saturation current depends on intensity, not on frequency. So here current does not depend on frequency of the incident light. Means option 4 is independent of frequency. Here in this question, number of photoelectrons emitted for light of frequency this is more than the threshold frequency is proportional to. It means if intensity increases means the energy falling on the cathode per second per unit area increases, means intensity. So number of photons falling on the cathode per second also increases. This increases the intensity. By increasing the number of photons falling on the cathode increases, then intensity increases. It means option 2 is correct. In this question, the momentum of electron is changed by P and de-Broglie wavelength changes is 0.5%. The initial momentum P we have to find. So we know lambda is given as h upon P, or P will be h upon lambda, taking the log and differentiation. This is a constant quantity, so differentiation will be 0 here. The delta P upon P and delta lambda upon lambda in percentage 100. Here the wavelength change is 0.5% and delta P is P. Let us the original value is dash. If we calculate here P dash by cross multiplication, it will be P into 100 upon 0.5. So it will be 200 P. Option 1 is correct. Hello, in this question, photon of energy E ejects photoelectron from the metal surface, so work function is W naught. If this electron enters into a region of uniform magnetic field in a direction perpendicular to the field and describes circular path of radius r, then r will be h nu equal to work function kinetic energy half mv square equal to photon energy is given in the question is E minus W naught. V square will be 2 E minus W naught upon m root of it. The speed of the electrons. And this enters in the magnetic field perpendicularly. Let this magnetic field here is inward magnetic field, and this is the electron negatively charged moving with this velocity perpendicularly will be in circular motion like this. Radius is r, so radius r is given as mv upon qb. q की जगह हम e ले रहे हैं, मास अपॉन से e v, वेलोसिटी की जगह 2 e minus w naught upon m root of it. So रेडियस विल बी कट के अंदर हो जाएगा 1/EB m कट गया 2m E minus W naught. So this is the fourth option correct. Hello, in this question we have to learn it to establish that electrical charge is quantized. Quantization means charge, total charge on the ball, on the ball here is given by milliton. So should be fundamental charge E, and how many charges are there? It should be integer. So charge on electron established quantization nature given by the milliton. So option is correct. In this question, an electron is moving with the initial velocity v is equal to v naught I in along x-axis in the magnetic field acting along y-axis. Then we have to find out the de-Broglie wavelength. De-Broglie wavelength is given by h upon mv, and we know speed v naught moving along x-axis and magnetic field along v naught along y-axis. But no magnetic field can change the kinetic energy as well as speed. It can change only the direction. So if speed remains the same, then V is same, M is same, H is same, so lambda is constant quantity. It is not changing at all. So option 1 is correct. Hello, in this question, monochromatic light means single wavelength. This is given 667 nanometer produced in helium neon laser. This is the power 9 milliwatt. The number of photons arriving per second on the average at a target radiated by this beam means we have to find out number of photons means n. Power is energy h nu or hc by lambda of one photon. If let n is the number of photons falling on the cathode per second, then it will become energy per unit time means power. So P is here not the momentum, but it is the power. We have to find out n P lambda upon h c. P means 9, milli means 10 to the minus 3, lambda 6, 7 nanometer means 10 to the minus 9. H is Planck constant, c speed of light. If we solve it here, n comes roughly 3 10 per 16 per second. So option 1 is correct. Hello, this question, a phenomena of photoelectric effect was discovered, suggested by say Einstein, but practically demonstration given by the Henrik Hertz. So option second is correct. The photoelectric threshold wavelength, lambda naught, energy of the ejected electron from the surface of the silver, and by instant wavelength lambda. Here we know photoelectric equation Hc by lambda equal to Hc by lambda naught. This is the threshold wavelength plus kinetic energy of MV. So kinetic energy is given as Hc 1 by lambda minus 1 by lambda naught. Taking LCM here, lambda naught. So lambda naught minus lambda. This is the kinetic energy expression. Option 4 is correct. Hello, in this question, electron used in the microscope when the accelerating voltage is 25 kV. If voltage increasing to 100 kilovolt means 4 times, then wavelength will be. So here the de-Broglie wavelength lambda is given as h upon 1 mv or p, or h upon p means 2 m e means energy is the energy. So energy and work done. So 2m q into v. V is the voltage. Now everything is constant. In that case, lambda is inversely proportional to root of V voltage. Now, lambda 2 upon lambda 1 will be V1 by V2 voltage, and initial voltage 25 kV, 100 kV. It means 1 by root 4 and 1 by 2. So, lambda 2 is lambda 1 upon 2 is decreasing by time. So, option 2